Okay, now I'm going to change subject again. It's going to be pulled together at the end. We're now going to talk about the Earth and the Moon. Spacecraft take lovely pictures these days. So this one was taken from 204 million kilometers away by Mars Reconnaissance Orbiter using a camera, and that is us and the Moon. And this was taken more recently, which is a very cool little video. And this was during the flyby of Juno. Juno is a spacecraft that was launched, did a loop around the solar system, went back to the Earth, did a high-speed flyby, and then whoosh out to Jupiter. Now it should run, if it's going to behave itself. Yes. Now this is from the spacecraft, and you watch this. The spacecraft is flying towards Earth. I don't know if you can see there's a little moon there. It gets bigger because the spacecraft gets closer. But this is the Moon. The reason it's spreading out and getting bigger is because the spacecraft is going whoosh straight towards the Earth. Because what it does, it almost crashes into Earth, but it uses that fall to accelerate out to Jupiter. But that just gives you a flavor of the relative sizes of the objects we're talking about. So I'm going to stop in a moment, so I'm not going to crash. Boom. Okay. Now, where does the Moon come from? Actually, 1881, this geophysicist, British geophysicist, already came up basically with the idea that some large object, some extreme tidal forces ripped the Moon out of Earth. And he also agreed that the Pacific was the site where the Moon took off. So that's Osmond Fisher, very intelligent and far-thinking person. Okay, I won't dwell on this too much, but basic parameters are the Moon is about a third, well, 27% of the Earth, but I mean in diameter, but it's only 2% of the volume. That's just basic geometry. The rocks of the Moon are much lower density than the rocks of the Earth, so in fact it's only 1.2% of the mass. And the Moon's mass can be explained by being made basically of basalt and granite, but not with no iron core. And the volume of the Moon is the same volume if you took off half the surface of the Earth down to 86 kilometers. Okay, Moon formation theories. I won't go into too much detail here, but there have been a variety of different ideas. At the end of the 20th century, giant impact model was the favored model. The Apollo missions eliminated the capture model because they showed that the Moon rock was very similar to Earth rock. And so the current idea is that this Mars-sized impactor whacked into the Earth 4.5 billion years ago and sprayed off lots of material. But the important point is when you have such a collision, then what you're going to spray off is vapor and very hot liquid rock. You're not going to get chunky bits of solid rock. And also you may not be familiar, but there's such stark contrast between the near side of the Moon and the far side of the Moon. It's really asymmetric. And there's a nice picture of the giant impact, famous, well-known picture. But as I say, the problem is that Moon rock is not remelted Earth rock. I told you, Apollo mission, they've already discovered that the Moon's rocks are the same as Earth rocks. It's like the Moon rock's it's like Earth rock's been cooked before it landed on the Moon, but not at very high temperatures or for very long. And you can measure this in terms of depletion of various volatile elements from the rocks. And these are just different types of Moon rocks. Basalt, that's breccia, and that's a granite-like rock. In this analysis of the Moon rocks, they found this thing called the siderophile problem. Basically what it is that the Earth was made from the material of certain types of meteorites which contain these elements that normally dissolve very efficiently in molten iron. And you find these meteorites, these primordial chondritic meteors, have the same ratios of these iron-loving elements, but the amount in Earth crust has been heavily depleted because all of these iron-loving elements were dissolved into the hot iron of the young planet. The problem is that, and these are the elements that have high affinity for molten iron. The problem is the Earth rocks and Moon rocks have almost the same proportions of these siderophile elements, which suggests they're made by the same process. The only problem is that the Moon doesn't have a core. and so it never had a molten core. Okay, another problem. Lunar rocks are magnetized, but they're randomly magnetized, but there's no magnetic field on the moon. And the best explanation for these magnetized rocks on the moon is they're magnetized on Earth. And so by this year, I think there's pretty much a consensus that moon rock equals Earth rock. I mean, it's the same stuff. And you can look at it in many different ways, oxygen isotope ratios, you can look at chemical composition of rocks, the process rocks went through to get created. And in addition, there's no evidence of this alien impactor. No one's found anything that could be a signature of this so-called rogue planet that whacked into us. Another story is that recently they've been finding heavy elements on the surface of the moon. This is not in the core crustal lunar rock. This is on the surface, in all the breccias and the creep rocks. Again, it's very strange because it seems that the moon gets showered with supernova debris on a regular basis, and so do we, because certainly in the Permian destruction layer, even in the Pleistocene destruction layer at the end of the Ice Age, you get a lot of this creep-like material. Something's coming through and dusting us with this stuff. Another point to focus on is the asymmetry. I mean, if the moon really formed from molten rock, it would be much more symmetrical. It's very asymmetric. So you've got all these, big depressions, you've got mountains on the far side, you've got the strange Maria as well. Inside the moon, it's strange, the far side, you've got a thick crust, near side, you've got a thin crust. There's evidence of lots of cracks everywhere. The centre of mass and centre of geometry are different. How come that happened? What process made the moon? The Apollo missions, when they'd finished with the lunar lander on Apollo 12 and Apollo 13, they crashed these spacecraft into the moon and had seismic detectors on the surface. And what they found is the moon resonates. It's actually got cavities in it. So there's something strange about the internal structure of the moon as well. I mean, the things we see when we look up in the sky every night and you see these dark patches on the moon, the Maria, there's also something strange about them because they are basically disks of basalt rock, which is identical to Earth basalt, the ocean floor rock, but they're just like pancaked down on the surface of the crust. They're not something that's bled up through they're not a volcanic feature. They're something that's landed on top of the moon. And again, just stressing that point, the lunar basalt and the Earth basalt is the same stuff. And the only slight difference is that the lunar basalt's got more oxygen in it than the terrestrial basalt, and that can be explained by the fact that the basalt was exposed, Earth basalt was exposed to oxygen temporarily as it ripped out through the atmosphere. Another story is connected to the age of these rocks. Okay, when the Apollo missions were done, they found this strange problem with dating. That is, the Maria basalt and the Highland anorthosite white lunar rocks were different ages. And so they came up with this idea of what's called late heavy bombardment, trying to explain it. But in fact, a better explanation is these rocks came from Earth, and the outer rock of the crust of Earth cooled first and became solid, and then afterwards, the inner upper mantle rocks became solid. It was about 800 million year difference. And that's why you get different dates for these two types of rock. Other things, when you see pictures of the moon, you don't often see these, but they're real pictures from Apollo 15. You've got a river, bit worrying. You've got a cliff, which is sedimentary, sedimentary layers. Those are made normally on Earth in an underwater environment, so it's building up strata of different rock. What are they doing on the moon? There's not supposed to be any ocean on the moon, any water. It's another picture from Apollo 15. Okay, you've got these mountains. Again, you've got this like stratified rock. You can see it there. And the rocks on the far side are primarily this rock called anorthosite, which is in fact formed on Earth at the base of the crust, not on the surface. It's something at the interface between the mantle and the crust. And I'll go into that in a moment. And this is called the anorthosite problem. So this is this stuff I'm talking about. So this is the geological column going to the center of the Earth. If you just take that very top bit, that's the crust. And that bottom of the crust, this is the interface between the mantle and the crust, is this stuff called anorthosite. It's a white rock which has been recrystallized and recrystallized in a sort of geological process. It's very pure white material. And the problem is out there on the moon. And how did it get there? And, okay, this was brought back by Apollo 15, and this was found on some hillside in Canada. The same stuff. Basically, the same rock has the same dates. It's about 4.5 billion years old, and it is formed by a sort of cyclical recrystallization process. So it's a very pure material and crystalline. But what we understand about anorthosite is this, that it's about half the mass of the crust. It's a heat-processed meteoric rock called anorthite. And it's a slow sort of process that occurred over a period, probably 500 million years during the formation of our planet. And it no longer happens because our planet is too cool near the surface. But there's a massive manufacture of this white rock, which mostly is on the inside of the crust, not the outside of the crust. So it's a big mystery. Why is it on the outside of the crust? It shouldn't be there. You know, it's supposed to be 50 kilometers down. But here we have a bit of Greenland and Canada, and there's anorthosite there. Now, in fact, when you study the anorthosite, you find not only is it in those two locations, but it's like there's like a drop zone right across the planet where bits of anorthosite have been dropped on the surface of younger rocks. In fact, when people studied these anorthosite plutons in Norway, you actually find the lower surface is bowl-shaped and heat transformed, and it's smashed down onto other rocks which are younger and also then become heavily fractured. It looks like this anorthosite you get on the surface of Earth actually dropped from the sky. Okay? So we'll get on to when and how was the moon formed. So just throw in a few more other strange features. You've got, well, summarizing, we've got anorthosite on the far side, which we said comes from the base of Earth's crust. We've got strange features like this basin here, the Aitken Basin, which is like 6 kilometers on average below the surface of the moon. Hard to explain if it was just a liquid rocks that solidified. The near side Mare area, also a strange story. How did they form? And finally, the heavy cratering you get on the far side is actually created by terrestrial material. It's not alien material. It's Earth rock that's made those craters. Then you get to this, which is something very strange. This was published in Nature a couple of years ago. You've got this strange square shape set of fractures in the near side of the moon. And this was discovered by 2 spaceships which were following the same path, and they could make very accurate measurements of the internal structure of the moon based on the gravity experienced by those spacecrafts. And so the data shows the moon is heavily fractured, faulted, and with strange cavities, and it's got a trapdoor for some reason. And in addition, there's a trapdoor on the near side, and on the far side you also get another square-shaped area. This is detected by the Clementine spacecraft, which is a high iron content zone on the far side. So there's some large-scale structure, internal structure on the moon as well. And finally, the thing that killed most of the other theories was this, that in the last 10 years, we're absolutely certain now there's water on the moon. And so all the other theories assume there's no water on the moon. So first is the anorthosite rock was made in a wet environment. The lunar basalt was made in a wet environment. You even get things like apatite, which is a high water content rock on the moon. You find water in volcanic deposits. You can launch probes at the moon's surface and you can get water flared up from the impacts. And it even has ice caps. So we really don't have we currently don't have a good model to explain all this data. There's another big problem. People assume generally the age of the moon is the same as the age of the rocks that you pick up on the moon. But there's a problem, because the more we understand about solar system dust, the more we understand the moon is probably a lot younger than we think it is, because you can calculate more or less how much dust should have accumulated in 4.5 billion years on the surface of the moon. And when they first did these experiments, they thought maybe got their calculations wrong, because they landed the Apollo spacecraft on the moon and they found 1 to 5 centimeters of dust, or I mean on average it's about 5 centimeters of dust on the whole of the moon. But when you now go to other solar system bodies, you find there's a meter of dust. So like on Phobos and Deimos and various asteroids, there's a meter of dust on these objects, which suggests that the moon is 20 times younger than a lot of these other bodies in the solar system. So the big question is, how old is the moon? You see hardly any dust here. Look, there's a footprint. There's no dust. The guys have been driving around in it. They're not wading through deep deposits. I mean, the evidence stacks up that the dust accumulation suggests 250 million years for the age of the moon. It coincides with the Permian mass extinction, the end of the Paleozoic era, age of the oldest basins, ocean floor rocks. How can all this be the case? So I'm suggesting this. Now this is, I didn't do this, this is on the internet. It's a very good new simulation program, which is almost a game. And there's a guy called Shenanigans who actually played with it, and it's really cool. And this, his idea is he put Earth within the Roche limit of Jupiter and see what happens. And this is a real physics model. It works. And we see what's happening is the surface of the Earth is being ripped off. If you put Earth close to Jupiter, that's what happens. And that's how the moon formed. That's how the ocean basins formed. Except it wasn't Jupiter. It was something else. It was this star core that did it. But this is real physics. It's not a fantasy. Okay. So the basic idea is the Caesarian Moon Birth. That is, the star core flew so close to us, briefly, there was a gravitational pulse that actually ripped off our crust on one side of the planet. It happened 250 million years ago and had a catastrophic effect on us. And the basic picture is, okay, this is actually 400,000 kilometers, about the current separation from the Earth to the moon. So this is, I've had to squeeze all the scales. And the speeds are important as well. So the velocity of Zeus is coming by at about 50 kilometers a second. The current orbital velocity of the moon is 1 kilometer per second. So what happened was there's this brief burst of tidal force, and it starts to accelerate all our crustal fragments out. But because Zeus is going away so quickly, it disappears, and then normal Earth gravity is restored. But by that point, the moon's in orbit. Okay? And in terms of the geometry, because I showed you the model that, in fact, it's in this model over here, that it's Zeus is orbiting almost perpendicular to the planets. So it came in from the north, and there's an orbital intersection. So around about June, we intersect with its orbit. And unfortunately, at that time, our orbital intersection was very close. And when we happened to be in the same place at the same time, you know, whoosh, we lost half our crust. So the effect was the main bulge towards Zeus was lining up with where the Hawaiian hotspot is. An equivalent bulge actually occurred in Botswana, and in fact you still find that bit of Africa has got a strange dome to it. No one can explain how it was formed, but it's a tidal bulge. And this whole process was responsible for cracking the crust. And so what we consider is actually Pangaea is the remaining part of the crust which had been broken. And the important thing is that 1 million kilometers, you have no gravity at the surface of Earth. When you get to 400,000 kilometers, you get negative gravity. So basically mountains can fly, everything can fly. It falls off, everything falls off the planet. So basically our planet was peeled. It's like take a hard-boiled egg, pull off the shell. That's what happened. And so we're talking about approximately 50 kilometer thick shells of crust and maybe another 40 kilometer thick of basalt. And it's not completely uniform, so where the Hawaiian hotspot is, there's a much bigger sort of digging going on in the center of the, where the center of gravity between the two objects was. You can calculate approximately how long it took. It took about 5 hours, basically, to rip off the crust. And then it took another 4 days for that stuff to move to the present orbit, where the moon is now. And so basically, the way the moon got up there, it was tugged. It's like a big tugboat, you know, it was pulled out into orbit. And because Zeus was moving much faster, it was then left behind. And the inertia of all that rock was so big, it didn't catch up with Zeus. Zeus took off and left the debris in orbit. And in fact, today, the moon still passes over Hawaii. I don't even know the latitude of the lunar orbit. So in summary, the age of the moon is the same date as the Permian mass extinction. The difference in age between basalt, the lunar basalt and the lunar highlands is just to do with the difference in time when the crust of Earth solidified. So the outer crust solidified first, then the upper mantle solidified 800 million years later. And it explains many things about the Earth as well. So age of the ocean basins, age of the land. And so in conclusion, Zeus performed a Caesarian on Mother Earth to give birth to the moon. That's the theory. Very straightforward. And one last thing, a prediction. If I'm right, we're going to find Permian fossils on the moon. I didn't do very good photoshopping because it ended up on the internet and everyone said, oh, they found them already. All right. So thank you very much for listening, and I hope I've opened your minds. So questions?